What are the characteristics of the cathode rays? The cathode rays start from the cathode and move towards the anode. And as they are starting from the cathode, that is the reason why we call them as the cathode rays. So here, from this particular cathode, they are moving towards the anode. The cathode rays are invisible, but their behavior can be observed with the help of fluorescent material such as zinc sulfide, so that a strong fluorescence is produced when the surface is bombarded by the particles. So whenever the cathode rays strike the zinc sulfide screen, we can feel we can observe the fluorescence there. So cathode rays can also produce phosphorescence. Example, television picture tube. The cathode rays travel in straight line in the absence of electric or magnetic field. And the cathode rays are deflected towards the positively charged plate in the presence of electric field and south pole in the magnetic field. And this shows that the cathode rays consist of a stream of negatively charged particles. And what are those particles? And those particles are called as electrons. So those particles are called as the electrons. So in this particular way, the electrons were discovered. And the name electron was suggested by a scientist named Stoney. The cathode rays produced are independent of the nature of the cathode material and the nature of the gas present in the cathode ray tube. Hence, we can conclude that electrons were considered as constituent particles of all atoms. So electrons are universe. So irrespective of the gas taken in the discharge tube, the cathode rays produced are independent of the nature of the cathode material. Let's see exactly how these cathode rays are produced. So whenever we are taking a gas in a discharge tube and we are maintaining a pressure of 0.01 mm of Hg, and whenever we are applying a high voltage of 10,000 volts. So then from the cathode, this is the cathode and this is the anode. So from the cathode, the rays are produced and they move in a straight line towards the anode in this particular way. Now, when we apply an electric field here, so when we apply an electric field, what happens? See carefully. Now these particles, they are bending or moving towards the positive pole. They are moving or they are deflected towards the positive pole. And this concludes that, or from this we can conclude that these cathode rays contain particles which are negatively charged. As the particles are negatively charged, that is the reason why they are moving towards the positive pole. Then the value of E by M, and the value of E by M, this is called as the specific charge. So what is specific charge? It is the value of charge upon mass. Charge upon mass, that is called as the specific charge. And it was found to be 1.758 into 10 power 11 coulombs per kg, where M is the mass of the electron in kg and E is the magnitude of the charge on the electron in coulombs. The charge on the electron, actually it was discovered by Millikan, scientist named Millikan. He had discovered the charge on the electron by an experiment called oil drop method. So we call it as Millikan oil drop experiment. Actually you will learn that experiment in 12th standard physics under the chapter atomic physics. So it's not a concept of chemistry here. And Millikan found that the charge of the electron to be minus 1.6 into 10 power minus 19 coulombs. So knowing the values of E by M and the charge of the electron, it is possible to calculate the mass of the electron, because this mass of electron is equal to charge divided by specific charge. So we get the final value as 9.1 into 10 power minus 31 kg, or it will be 9.1 into 10 power minus 28 grams. This mass is termed as the rest mass of electron. It has been found that the mass of an electron is approximately 1 by 1837 the mass of the hydrogen atom. So we can say that hydrogen atom is 1837 times heavier than that of the electron. and the mass of electron in relative units is 0.000548 AMU. So this is the mass of the electron in relative units. Now how can we calculate the mass of the moving electron? The mass of the moving electron we need to calculate using this particular formula, which is equal to rest mass of the electron divided by square root of 1 minus V by C whole square. And what is this V? V is the velocity of the electron. And what is C? C is the velocity of light. Now tell me what happens when an electron is moving with the velocity same as that of light. Means what happens when V is equal to C? What will happen? Then the mass of moving electron is equal to rest mass of the electron divided by 0. And anything divided by 0, that is nothing but equal to infinity. So mass of the moving electron becomes infinity whenever that electron moves with the velocity of light.